Hello and welcome to the course of time series econometrics. In this session, we are going to talk about what is time series data and how does it look like and what all we can see in a time series data, how it is to be used. So it is sort of a introductory session to understand the time series data. Now, time series, as the name would implicate, time is very important here, and basically you collect and arrange data sequentially over time. So that's basically a time series, okay? And you will come across this. The time series is basically, the data is generated through a stochastic process. So time series has to be understood as opposed to the cross-sectional data. In case of time series, the data is generated in a process. So we don't talk so much about the population, whereas in cross-sectional data, we talk about the population. In time series, we talk about the process. So data is generated through a process, and this process is stochastic process. Now, what is a stochastic process? Those who have done basic statistics or basic econometrics, I believe you already know about it, stochastic process and deterministic process and things like that. So in deterministic process, you already know about the outcomes, whereas in statistic process, stochastic process, sorry about it, as in stochastic process, you actually don't know about the outcome in advance. Okay, so this is where we call it, you know, you actually use a random variable for that, right? So you can also say the time series is a sequence of random variables ordered in time. Okay, so this is a diagram that we will often use, and this diagram is actually indicating the process. Okay, and here you have uh, data generated across different times, T1, T2, T3, T4 at the different time points, and where you actually generate data. And when you generate this data and you sequentially order them, you actually create the time series data, right? Okay. Some examples of time series. Now, time series is really, really very important, sort of data, because whenever you talk about business, you talk about history, or you talk about anything that like in day-to-day life also, uh, where you have certain temporal dimension, you use basically time series data. So, for example, in business, you look at weekly interest rate, for example, or the stock price. When you look at the stock price daily or price indices. Okay, in different companies, they can look at the sales figure that you achieve monthly or yearly. So all these are basically examples of different types of time series. Now we will look at some time series uh, you know data and how do they look like. So here I would take some examples from your textbook. The first example is about the annual rainfall in Los Angeles. Okay, and it has data of across 100 years, more than 100 years, where it shows annual rainfall. Now, the second, before we actually get into that, let us look at the second plot where we have actually plotted in a say chemical process. You produce some material and then you see the color property. Okay, and you see that you again get for in different batches certain color property. Now if you the reason I gave these two diagrams together, so if you see that these two diagrams are not exactly the same diagram. Okay, so there are differences, and this would be your pursuit when you actually try to understand time series, that how one series is different from the others, what are the properties. Now just looking at these two diagrams without knowing anything about time series, I mean, what you can see, what you can tell about this series. um, First, you see in the first diagram, I mean, what comes to my mind, if I just look at it from a layman's perspective, the first thing that comes to my mind, well, so it seems that there are sharp edges, okay? The rise and fall are pretty sharp, or it might be that every period is actually, every next period is actually going through a sharp direction change, right? So if the rainfall is pretty high in say 1884 here, if you see this spike here, suddenly there is a drop in 1885. Then again there are some spikes, 86, 87. Then again it becomes pretty high, maybe I don't know, uh, yeah, 85. I don't know, 87, whatever this is. So like 87, 88. Again, there are some fall. Again, like a little bit spike. Again, fall. So this way it continues. So it can be that every year is preceded by a, every so basically there is a difference between two. The like if there is a high rainfall in one year, the next year it is going to see a low rainfall. So and vice versa. Whereas in the other case, you see that it seems that perhaps there is some sort of relationship between successive periods, and that's a positive relationship. Which I mean, what I mean by that is, if the color property is high in this scale, or low in the scale, so the next property is not going to be significantly different from the previous one. So for example, if I look at from say batch 5 to batch 10, you will see each of these observation, the color property is kind of similar to the previous one. It's like slight change. Okay, now certainly there is a change in at 10, and it spikes, and then again it goes down at around 13, and then again 13, 14, 15, 16, 17, 18. It looks like they're pretty much stable here, and there is a fall. Okay, so again, I mean, you see that it's not as sharp as it was in the previous case. So it seems that there are certain sort of positive correlation between different you know successive period. Okay, now we'll see another one. We will see another um, diagram, and that is just a second, and that is basically abundance of Canadian hair. So this probably is, this diagram is representing the population of hair in Canada. Okay, now what you see here is that again, like the ages, the the number of hairs, say the y-axis probably is representing in millions probably. Okay, so number of hairs are actually not significantly differing from the previous year. So from 1906, maybe, like 6, 7, 8, 9, 10 is pretty consistently increasing. 10, 11, 12, and then there is a there is start of decline, you know and it continues to decline. Okay, 1915, 16, 17, 18, 19, and then again it starts to increase. So if you see, if you compare these two diagrams, you see there are more sort of like a periodicity here, right? There is a more periodicity. So let me use this term periodicity. We'll come across this. Well, so now when we are actually trying to look at the time series data that way, so what exactly we're trying to find out? Okay, so what are the properties? I mean, all these ups and downs in time series data, we need to explain what these ups and downs are, and how we can distinguish, how we can figure out the features in this time series data. So there are certain components of time series that way, and we'll just come to that. But before that, let us look at another time series data. So this is an example of actually global warming. This is the temperature deviation across the world from 1880 to 2000. Okay, and if you see in this data, so that this data from 1880 to say 1920, 1930, it was pretty stable perhaps, and from 1930 onwards, it seems that there might be an increasing sort of trend. Okay, so I use the word trend here. So it is like as if it is growing. The temperature, it seems it is growing. Though year to year there are a lot of variations, but overall it seems there is a growth in the temperature, right? Now let us look at another example. This is quarterly earnings per share for Johnson and Johnson, and this data is from 1960 to 1980. And you see here also year to year there are some variations for sure, but without any doubt we can see a very clear positive trend, right? It is increasing, no doubt about it. So this is one thing that one property that we will always talk about, that is the trend in a time series. Okay, if there is an increasing trend, if there is a decreasing trend. So all the examples, the two examples we used are increasing trend here. You can also have a decreasing trend. Okay, now let us look at another example. So it is average monthly temperature in Iowa, and when you take monthly temperature, you will see the temperature is increasing. Probably from March, April, and then it probably becomes high in the month of June, July, August, and then again falls, and in December it's the lowest, December, January, So the same pattern will be repeated across these different years. So this is something we call seasonality. Okay, so if the data is the pattern is repeating across time, so if there is a specific pattern of repetition that you see time to time, so you call it a seasonality. The next example is also an example of seasonality where you actually see monthly oil filter sales. So oil filters are sold to certain companies who manufacture certain product, and the product is actually dependent on certain market demand. Now, market demand may vary month to month for certain reason. So here you see it's like there is a repetition of patterns. It's like a small hump, then there's a big hump with a sharp edge. So the same kind of pattern is being repeated, like in every time cycle. Well, so this way we try to identify the different components of a time series. Okay, so we talked about trend, we talked about this is trend, we talked about seasonality. Now one more thing, we if you just draw a mean line in a time series data, so you basically what you get is called level. So level is not that important, we don't always talk about level, but it's just the mean value of that that time series data. Okay, so once you get rid of this level and seasonality and trend, what is left is basically the noise component. Okay, the white noise or the error basically that we see, which we want to be like independent and identically distributed. So we'll talk about it. So yeah, so these are the four components basically in the time series. So time series data has level, trend, seasonality that you see, and if you can take out everything else, so what is left is noise.